Hello everyone, welcome to Scalers YouTube channel. My name is Aditya. I'm currently working as a data architect at PepsiCo. In Module 5 of Data Engineering, we are going to talk about different activities which we use in Azure Data Factory. Welcome to Module 5 of Data Engineering. Today we are going to discuss the below topics. First, we are going to discuss about asset properties. Then I'll discuss about the CAP Theorem, very much famous interview question which is being asked in the design rounds for data engineering roles. Then we will see or look into delta life tables advantages, and then we will deep dive into the ADF activities, right? So first, we'll discuss about asset properties. So many a times you might get this kind of question, what is asset properties? So asset basically stands for atomicity, consistency, isolation, and durability. So what is atomicity? Atomicity. Every transactions which happens, I mean it can be any transaction, basically a banking transaction or any normal transaction, whatever happens should be atomic in nature. Basically it means like either all the transaction is successful or the steps within a transaction is successful or it is not successful. Ideally, to give a best example, let's say I have a bank account and I have transferred 1,000 rupees to one of my friend, right? So atomicity basically means 1,000 rupees being deducted from my account and 1,000 rupees going to my friend's account. It cannot be a scenario where 1,000 rupees has been deducted from my account but did not go into my friend's account, or money went to my friend's account but he did not deduct from my account, basically. Or it can be other way around. Money deducted but did not go, or money went but did not money did not go, but it was showing something like it reached to the friend's account. It means either the transaction is completely successful or or it is not successful. So let's say I have sent money from A is transferring money from A to B. Let's say, okay. So money from A deducted, money did not reach B, money from A not deducted, money reached B. So it means either, so if the money has been deducted, it should have reached B, right? Scenario one. So both of the activities should complete for me to say atomicity is maintained. If one activity is not completed, it means it's not atomic transaction. Case 2, if you see money from A not deducted, then how money credited into B? It can be from some other source. So if this is not deducted, money did not reach B. So both of the activities should be completed for the money to go from A to B. So any transaction should be atomic in nature. Transactions should be atomic in nature. Either all should pass or all should fail, right? If money is not deducted, then money should not reach B, because one is failing, other should not be passing, right? So either all should pass or all should fail. Ideal scenario, actual scenario, I would say, money deducted from A, money credited in B. Other scenario, money did not deduct from A, money did not credit in B, right? These are the actual scenarios for saying my transaction is atomic. So atomicity basically means Either all the parts of transaction is completed or successful, or if both the transaction activities are not successful, it means it is failed. So every transaction should be atomic in nature, right? Consistency. What does the word consistency mean? Let us understand. Consistency. So my transactions should be consistent. By the way, why am I using these terms consistent, atomicity with respect to transactions? So ACID compliance basically deals with OLTP system. When I talk about OLTP, it means online transactional processing system, right? All these rules apply for a transactional system. So what does consistency mean? Consistency means my transaction should be consistent, or in easy simple language, it should comply with the constraints of a transaction. Best example, I have 2000 rupees in my friend's account. Okay, I asked him to send me 4000 rupees amount. So as per the transaction, I asked him to send me 4000 rupees, but he only have 2000 rupees, right? Can he send 4000 rupees? No, because 2000 rupees is the only amount which he has in his account. He can transfer the entire amount in case zero balance account is maintained. If you have to still maintain some 500 rupees in the account, he can only send 1500 rupees. So there are some constraints being maintained. So whenever I'm performing a transaction, my database will see, okay, what is the minimum amount to be maintained in that account, and after that how much amount can be transferred. If the amount is sufficient, then only the transaction will happen. So my transactions should obey the law of consistency. My transaction should obey the law of constraints. If it is not obeying, it means consistency is not maintained, right? This is actually called as transaction being consistent. So transaction should be atomic. All the parts of the transaction should complete. Transaction should be consistent. It should obey the rules or the constraints, right? What is isolation? Isolation. Best example I can give is every transaction should be isolated in nature. For example, I spent money in supermarket. Okay, I received amount 1000 rupees from my friend. Okay, at the same time, I was charged 500 rupees for fast tag. Okay, fast tag. So I have spent some money in supermarket. A, this is part A. I received some amount from my friend, part B, and also I was charged at the toll 500 rupees as part C. All these transactions are happening in a serialized manner, right? And these are all isolated. So whatever amount I have in my account, let's say X, right? Initially I spent some amount. Let's say I have spent 2000 rupees, X minus 2000. Then I received some amount. So X minus 2000, I'll get some Y value. Then I received some amount, Y plus 1000 rupees, right? I got some Z value. Now Z minus 500 is the total final value which I'm left with, right? Final value amount I have in account. So all these transactions are happening one by one in an isolated fashion. It's not like the money which I'm receiving 1000 rupees from my friend, from that some amount was spent and then that amount got credited. No, all the things are happening in a serialized fashion based upon the timestamp, and then these are all isolated in nature. There is nothing like, it's always like first come first basis, right? And all of them are isolated. This transaction will not be aware of the next transaction happening. So that is called as isolation. One transaction will not know what is happening with the next transaction, whether it will be a deduction or it will be a credit, right? So all my transactions should be atomic, it should be consistent, it should be isolated. So the final word is durability. The transactions happening should be durable or accurate. Basically, I should rely on a principle of transactions that that is safe, reliable, and durable, right? Basically, when I'm putting some amount in my bank account, I should not be worried about that amount. Okay, whether tomorrow it will be lost or tomorrow because of some transactions happening, the money will not be sent or deducted from that account, right? So the transactions what are happening should be reliable, should be durable, and only when it is accurate, then only people will be doing transactions from one account to the other. That is why all the four components, atomicity, consistency, isolation, and durability, basically reliability of the transaction, is very important. And if I go back and search in Google, if you search here, ACID compliance, just search ACID compliance, and if you open any of the documents, either it is from MongoDB, you can see I have given the same example what is being taught over here. Either everything should succeed or nothing should succeed, right? Consistency is basically database constraints. It talks about obeying the rules or the constraints of any transaction, right? So anything if it goes beyond if anything goes beyond the constraints, the transaction is supposed to fail, right? Isolation because every transaction is happening in an isolated environment. Nothing, one transaction will not know about the next transaction, right? So same example, if you have 200 rupees, you are trying to withdraw 100 rupees at the same time, all these transactions happen concurrently, ensuring that your ending balance is zero, not 100, because transactions impacted each other. Okay, so all the transactions are happening in an isolated environment. Durability is nothing but ensure what happens once the transaction is complete, the changes in the environment. So durable is also basically whenever transaction is happening and if something got failed, you have still a snapshot of each and every transaction being maintained in a database to see the before and after picture of a database, right? Or the amount which you have in your system. Basically, let's say I spent 500 rupees in a supermarket, the amount got deducted and it did not reach out to the merchant, let's say. Because of some power failure, the amount did not happen, the transaction did not happen properly. In that case, the amount whatever has been deducted should be rolled back to my account because of the acid property, number one, also because of the consistency. Since amount got deducted, it should reach to the merchant. If it has not reached to the merchant, it is somewhere in the middle, right? So it has to be rolled back to my account. So durability is basically reliability of a transaction. So that's why I told you you can go through this document from MongoDB. I have also used it for preparation. Read about it. Basically, what is asset transactions? Why as atomicity, consistency, isolation, and durability is very much important, right? Now let us go back. So I have discussed about asset properties. Now let us talk about the very much important concept which is highly asked in the interviews called as CAP theorem. CAP theorem, I think it was also called as Laplace theorem. Let me see. Brewer's theorem. Why we called CAP theorem as Brewer's theorem? Because it was named after the scientist Eric Brewer. Okay, and every distributed system, whatever you take in the market, should work upon this CAP theorem, right? So many a times interviewer usually ask in the interview what is CAP theorem, why it is very much important. Any system design round, uh, if you are adding this CAP theorem in the concept, it basically shows the kind of approach you have, the kind of concept you have, right? So let us discuss this also. Let's see practically, also theoretically, what CAP theorem means. right? So I'm taking three circles, part of Venn diagram. Here I can write it as consistency. Let me know if it is not visible. Consistency, atomicity, and this is durability. Okay, sorry, this is partition terms. Again, availability, partition, tolerance. So, big data concept says there is no distributed system where there cannot be any network breakage or network failure or network partitioning, right? Let's say these two systems are connected, they're distributed. I can take one example. Let's say system A, system B. Both are distributed systems. Distributed system means it has a worker node, it has a master node, it has multiple worker nodes, right? So let's say there are two distributed system A and B, right? Cluster of machines, I can say. So A is communicating with B, right? So that both the copies A and B, you can just treat it like copies of the data working on two different distributed system or parallel processing systems, right? A and B together are working, to fasten or to quickly process the data. Let's say A and B are mirror images, right? So how is A and B connected? A and B is connected by using some network. Okay, let's think of A and B as connected through a network. Connected through network. So people will ask, okay, why A and B is connected through network? A should know what is happening in B, B should know what is happening in C. Since both of them are mirror images, the final output of A should match with the final output of B. Now let's say in an event, there is some network failure, right? In an event of a network failure, what's happening in A will not be known by B. What's happening in B will not be known by A. Both are now will be treated as different isolated systems, right? Previously, both are mirror images because they have well bound connectivity between them. But now, if the connectivity is broken, A and B will be, working as independent systems. They don't know about what is happening in them. So, in that case, CAP theorem comes into picture or Brewer's theorem comes into picture. What does CAP theorem states? In an event of a network failure or even in an event of a network partition. Why I'm saying the word partition? Because the network has been partitioned or divided. In an event of a network partition, I can either maintain consistency or availability, but not both. Let us now understand this sentence. First, I'll write the entire definition, and then I'll explain you basically what it exactly means. In an event of a network partition, basically a network failure, we can either maintain consistency or availability, but not both. What exactly it means? Let's say when there was a good connection between A and B, any transaction happening in A will be somewhere be reflected in B also. Let's say today there's an account X which is maintaining 100 rupees. Okay, some 100 rupees got deposited from some other account. So total amount which is now converted is 200 rupees. The same data will be reflected here. X equal to 200 rupees. X equal to 200 rupees over here also, right? Because there's a well network maintained between A and B. So any transaction happening in A will be reflected in B, provided there is a very strong network in between them. So the data, whatever is seen here, is available here. Number one, availability concept is met, and the data whichever you see here is equal to the data which is present here. So both the data are equal. So it is consistent. So both of them are consistent and available at the same time. But in an event of a network partition or a partition tolerance, I can either choose between availability or I can choose between consistency. So in an event, in an event when my, let me expand this, or else it will become difficult to type. In an event when my network is down, I can choose between data availability or data consistency. So what does this mean? It's a very, very beautiful concept derived by Eric Brewer. So let's say if there's a network partition, or let's say the network is broken between A and B. So I can choose whether I just need to show some data in A and B. For example, I'm not concerned with the accuracy of data. I can show, okay, X equal to 200, but B equal to 100. I can show the previous snapshot of B because the user is not worried about the data what they're seeing. Okay, so in case when availability is the priority, I can write here. In case when availability is priority, I will compromise what? I will compromise consistency of the data. Data will not be consistent between A and B, right? Because for me the highest priority, so I just need to show some of the other data. Let's say best ideal example I would say is, if suppose a web application is down, okay, and they have some data in it. People are not consuming the data, but they just want to see the pictorial representation of data through a Power BI report. They just need some kind of graphs over there. In that case, they're not much worried about the data which is they're consuming in terms of value, but I mean in terms of accuracy, they're not much worried about that accurate value, but they only want the data to be displayed in the form of chart. In that case, availability of data is much more priority for me than the consistency of the data, right? But now there is another example. In case consistency is important, then availability has to be compromised. It means whenever a network partitioning is happening between A and B, it's okay till the time both the values of A and B should match, right? Till that time, I will not display any of the values between A and B. Best example is your banking system. Let's say a banking system is down. In banking system, consistency is highly important, right? I cannot just show any value to the customer. The customer might be overwhelmed seeing the amount in his account, in his or her account basically. So I should give utmost priority to the data consistency than data availability, right? Because for me, my customer should not be worried about seeing a very lesser value in the account or seeing a very high value in the account. Obviously, when people see a high value, they'll be happy, but I should not compromise on the consistency or the accuracy of the data. So that's a place where consistency is highly important than availability. So it depends upon the user what is important to them, either consistent or data availability. I just need to show some of the other data. I'm not worried about the value or the accuracy of the data. That case, I can just show some of the data, and A and B are not equal. Okay, but consistency is highly important till that time consistency is maintained. So when the consistency is maintained is basically when I'm able to generate a network between A and B. Till that time, I will not display any data. I will generate a network. I will generate a secondary network between A and B, right? Let's say once I have generated a network between A and B, let's say I have generated a network between A and B. Till the time the network is generated, I will not show any data, right? But once the network is generated, I'll wait till the time A and B are showing both the values. And once both equal values, and once the equal values are shown, then I will say, okay, my data is now live. You can go and consume the data. This is called as CAP theorem. So there is an event whenever there's a network partitioning, I can either choose between consistency or availability. So I can have CP, AP, and AC. So let me show you this document, which is on CAP theorem. So CP and AC, you see this diagram, right? Basically this part. Let me take a diagram. Let me take this thing. So in an event of a network partitioning, I can either have consistency or partition tolerancing, CP, or I can have availability or partition tolerancing, right? But if there is no partition tolerancing, basically when I have a strong network between A and B, I can have both availability of the data as well as consistency of the data. So this part is called AC. AC, CP, AP, right? Always visualize this example of a bank account. You need to have a consistent system. Consistency of data is highly important in that case. Availability is secondary, right? Let me see if the recording is happening. Yes, it is happening. So I hope you have understood CAP theorem. Now I will take and we'll move to the next concept, which is again very much important. So CAP theorem, I can write, it is also called as Brewer's theorem. Just writing one liner note so that you can also make a note of it. Uh, in the event of a network failure or network partitioning, I can only choose between data availability or data consistency. But in case I have a strong network, I can have both data availability as well as data consistency, right? This is called as CAP theorem or Laplace LAP. This is also called as Laplace theorem or Brewer's theorem. These are like completely interchangeable, but yeah, be prepared, if you're going for a design interview. Cool. Now let us understand delta life tables. Very, very important topic, guys. Usually asked in the interviews. What is delta life table? What is the advantage of a delta life tables? So that there are two types of tables. One is data lake tables. Other one is called delta tables. So any table which is built on top of data lake data is called as data lake tables. If we have some properties invoked which makes it much more robust, much more stronger in terms of performance, in terms of the way it processes the data, then it becomes a delta table. So I'll basically talk about the advantages of a delta table. Over data lake table. First one is asset compliance. So what is asset compliance? My delta table, whatever I am preparing, the delta table, whatever I am preparing, it supports asset compliance. It is asset compliant in nature. Basically, what all transactions are happening in this delta tables are as per the transaction rules of asset properties. Basically, it should obey the law of asset properties of a transaction. Uh, the transaction should be atomic in nature, it should be consistent, isolated, and it should be durable. We already discussed above. So always remember, like, my delta life tables supports asset compliance, right? Which is not possible in data lake table, but yeah, delta tables always supports asset compliance. So I can write here delta live tables always support asset compliance properties. Number two, schema evolution. So what is this term called schema evolution? Let's say I'm having some tables which are used in the downstream. Okay. So I have one table in the source, right? I bring that table into target layer, let's say data lake. I have this table in SAP HANA, let's say. Okay. I brought this table into target, which is our data lake. I have done a lot of transformations in the table to get some kind of columns in the table, right? Tomorrow, let's say business comes back and say, hey Aditya, this table now has 50 records. Initially it has 35 columns. Now it has, let's say, 50 columns. So tomorrow business will come, hey Aditya, we are going to send you remaining 15 columns, which are the new columns, and every table from top to bottom has to be changed. So this will be a very big change in case my schema is fixed. But in terms of delta live tables, the lives of a data engineer becomes easy. Reason being, schema is evolving in nature. Basically, the schema is not rigid. It can increase or decrease based upon the needs of the infrastructure of the business. So schema on read is basically uh, whenever the data is being read, the schema evolves as per the data, whatever is being read, right? Initial days, the tables, whatever we used to build, were schema on write. We used to define the schema at first, and whenever data used to come, it should fit in those schema only. Schema on read is basically schema is created when the data is being read. So now, for example, data has 35 columns. The schema will have 35 columns. Tomorrow, if my data has 50 columns, the schema will evolve its shape so that it can include the remaining 15 columns also, right? So schema is always evolving depending upon the type of data or depending upon the size of data. Delta live tables support schema evolution. Schema on read is enabled whenever you are using delta live tables. Number third important point, time travel. Time travel is enabled on delta live tables. What does it mean? Basically, it's nothing but a feature of an audit table. I can go back in any point of time and I can fetch the records of that particular timestamp. Let's say 2015, someone who went to a supermarket purchased 500 candies of a particular company. So I can go back to the time of 2015 and fetch all the records of a particular timestamp to see whether those 500 candies were bought by a single person or not. So time travel is enabled on delta live tables only, which helps us for logging. Also, I mean, which helps us for storing the log files or audit the tables. So delta live tables support time travel. It's a very important feature which helps the user to go back to a particular point of time and pick up the data as per the requirement. This feature was not enabled in data lake, which made the tables quite clumsy to be queried. That's why delta tables helps us to go back to any point of time, querying the data, helping to retrieve the right point or right set of data. Right. Number four, compaction. I can write as a performance. So performance of table when you're using delta live tables is very high uh, because of two reasons. Number one, the format of the data, the type of the data where you're storing, it is either Parquet or it can be ORC. In case of Hive, it is ORC, optimized row columnar file format. But in terms of Databricks, we'll be using Parquet format. So performance of our tables has increased robustly over the past few years because the compaction of the data is happening. Because whenever you're storing a data in a Parquet format, the size of data which is being stored actually is so compact in nature that it takes very less amount of space when being stored in the data or in the database. So this enhances the engine processing time. Basically, it goes to that particular point of time and fetches the data, right? Performance of engine has increased over the past few years because of data compaction and the way data is being stored, right? So these are the major advantages of delta life tables on top of data lake tables, right? You also have another feature called as Unity Catalog. I wanted to stress on this area. Unity Catalog is nothing but a catalog of data. This is, let's say, this is a book, kind of a book of data which has indexes or which has page numbers of different chapters. Okay, so I can use the index to go to a particular page of the book to read that particular chapter, right? I need not read the entire book. I can just go to that particular chapter which I need to revise or read. So how I'm going to go? I'm going to read the index, see the content, which content is present in which page of the book, go to that particular page and read that particular page, right? So how this happens in the data is basically by use of by the uh, by the new concept which is called as Unity Catalog. Unity Catalog is nothing but a catalog of data. Now, if I want to scan through the complete data, it is very difficult. So to quicken up this process, we have something called as index. Index will basically take me to that particular page of the book or to that particular point of the data which a user has asked to fetch. So I can go to that particular chapter, tell the user this is the chapter from which the data has to be retrieved, right? So it takes the index will help us to query the data very fast and it will fetch the result in a much more fast pace when compared to how it was handled before. So Unity Catalog is a catalog of data. By using indexes, our data search speed has increased, and that will also fasten up the querying speed of the data, also the processing speed of the data. Basically, the data which is being fetched will be fetched in a much more faster rate, right? So I have covered ACID, CAP theorem, and advantages of delta table over data lake tables. Now let me go through the activities in ADF. So let me go to monitor tab. So I have already explained different uh, activities before, but yeah, I can go through a very small example with copying of multiple files. So if you see, so copy data activity is basically an activity in Azure Data Factory which is used to copy the data from one source to a sink, right? Uh, if you see on the left side, I have created one activity called as copy multi-files activity, right? Uh, you can go to general tab, you can give some other name, it's okay. You can copy multiple data, let's say, copy multiple data, and you can hit on publish. So the data, the activity name got changed. Source is basically I'm giving a source data set. I created one source data set. This is I can just open it up. It is a CSV format. So data set is nothing but structure of the files, how it is being maintained. So in my source, I have CSV files. That's why I created a CSV file dataset, right? I already have a link service which is used to connect my ADF to that dataset. So my link service is already created, right? And I want to pick up some bunch of files which are in CSV format from one source and I want to paste them in target. So this is my container. Okay, there is one folder called source and there are some file names. If I click on browse, you see ADLS container. I have some source and these are the different files which I have. So I want to pick up only those files which are ending with .txt or .csv. Let's say .csv. If I go back, so I'm picking all the files by using this data set, and part to file list is basically source list of files.txt. So list of files.txt is basically having multiple files or those files over which I wanted to create a list and I want to iterate over those lists to pull those files, right? So if you see the sync, so in this file, list of files, basically this file, I can't save it right now. Let me try if I can save it. Save as, download. Let's see if it is being saved. But yeah, I can show it in the portal only. Instead of using this, I can show it in the portal. I hope it will not ask me for authentication right now. I can go to home. I'm going to the container. Source. List of files.txt. Okay, download. Let me see if I'm able to download it. .text file. Save. Let me try to open it for you. Open with Notepad. So in a list of files, I want to copy or I want to pull these three files: employee lab.csv, json file.json, text file.txt. Okay, if I go back to my ADF, okay, so basically in my source, I have given the dataset name. You can give any dataset name. You have given the container name, the folder inside the container name, and the file name. Okay, file name you have not defined yet because you are passing a list of files which you need to copy. So we just gave the path over there, and path to the file list is basically this is the file which has a list of files which you need to copy. And if you go to sync, again you have a target data set. This is again a CSV data set which will help us to connect my ADF to the target, which is again in the format of a CSV. So my final files will be in the CSV format, right? So just think of like this. My ADF is used to pull the data from source to sync. My source is nothing but CSV file. I'm pulling the data from a source container in a folder. I'm pulling the data which is present in the CSV format, and I'm dumping the same data in the CSV format. So both my source and sync dataset will be in CSV format, right? Link service, you can use the same link service, and you are now pulling the data from source and you're placing them in target. So if I go back, you have a target folder, right? And you have something called as all these files which are coming. So if I run this pipeline, if I go back, you have not defined the file name because automatically all those three files which is there, it will load. So what I'm trying to do is I'll go back to the main pipeline and I'll try to debug it. Let's see what happens. All my three files will be copied from source to sink, right? And the timestamp will be updated. So currently, without seeing, I mean the timestamp was on 8th Feb, JSON file.json employees.csv. Now we have to see the timestamp should change. It should reflect 13.2. So let me see if it is completed. Succeeded. You can refresh. You see 13th Feb, 13th Feb, and the other one employee lab.csv 13th Feb. All the three files got loaded from source to sink, right? So this is very much important topic. To copy multiple files, you can just pass dataset, right? You can pass a dataset. Basically, you can create a source dataset, and you can create a file list, right? Create a list of file, store it in a source container, pass that list of that file basically, which is nothing but a list of files with a source dataset. Open the source dataset, ensure the file list, the file which is being used is in the same directory what you are passing, and go back here, go to sync, open the dataset. Target is basically where you're finally loading your data. Make sure it is same. So basically you are iterating over that file which has different list of file names which are passing in the source path as a list of file. I have debugged it, and you can also practice the same thing. There is one more copy activity which I wanted to show, is to copy the data from SQL table to ADLS. So you can see this copy table activity. I can write it as copy SQL to ADLS, or I can just write short form copy SQL ADLS dash ADLS. Okay, I can use dash also, not a problem. So if I go to source, my source data set is nothing but a SQL server. Okay, if I click on open, you can see I have created a link service to connect to my SQL server. If I click on test connection, you see I am able to authenticate my SQL server, right? I am basically pulling down data from a SQL server, and I'm pushing it to one ADLS storage account, to a container. So my source is nothing but SQL server, right? I am basically pulling a complete table and pushing it to ADLS, right? If I click on open, this is a table, sales items. This entire table I'm moving it to SQL, from SQL to ADLS, right? So if you see here, my source is nothing but a SQL server dataset in the format of a SQL server. So I click on open, you see this table basically in a database. I have this table. DBO is the schema or the database name. I have this table, sales item. Entire table I'm copying from SQL Server to ADLS. So if I go back, right, and sync is nothing but my target where I'm putting it. So target again is a storage account, and that storage account target I'm using a CSV format dataset, or you can use any dataset where I'm loading my final file. You can click on open. Since I'm connecting to a CSV file, I mean my final table, whatever I'm putting, it should be in the CSV format. So I'm using CSV dataset. Link service, we already have it, so we have used that. Container target sales items table. So if I go here, container target sales item table is nothing but the table which is derived from SQL Server. If I go back and if I run this pipeline, debug, here you can see it was copied on 12th of Feb, right? I'm running it again, we'll see it is running. The timestamp should change. Let it run for some time. And once it is completed, we'll see the timestamp to be updated. I can refresh it once. So it will start my SQL Server engine, and it will copy the data from SQL Server. From that particular database, it will pick up that table, load it in CSV format, and dump it in my ADLS, right? I can just refresh it. You see now timestamp will change from 12 to 13. Refresh. Timestamp has been changed, right? Let me go back. So I have covered these two activities, right? Copy data is nothing but one of the most important activity in ADF. It is used to copy data from source to sink. Source can be ADLS to ADLS, SQL Server to ADLS, any format, right? Now let's go to for each activity. For each activity is kind of an iteration, right? Like for loop in a code, we have a for loop in ADF to iterate over something, right? So if you see this activity, we have two different activities. One is for each activity, and we have one lookup activity. Lookup is basically to find something. So they have given this activity name as lookup. I am looking up a source system, right? Basically, I am looking up into a SQL Server source. If I open the data set, I am looking for this table, sales items table. Okay. If I open this data set, I am looping basically. One second. So for each activity means I'm for this first one is lookup activity. I'm looking up for SQL Server database DBO. Inside that, I'm looking for a table called sales items. Okay, I'm looking for that table name, right? And I'm not passing the entire table. I'm using a query. So what query we are passing? Select star from information schema dot tables, where table type is base table. So select star from information schema dot table. So basically select all the tables in this schema where type of table is base table. Let me cancel it. So from list of tables, I am taking only that table where the type of table is base table. So I'm looking out for a base table, right? Let me go back here. I'm looking out. I'm passing a SQL query. It goes to that uh, schema name dot sales items. There it will run this query, and it will go to for each activity. Then basically it will pick up all those tables whose table type is base table. Let's say there are five tables, but it will iterate over all these five tables. So for each activity, if I go inside settings, items, basically based upon the output value of this lookup activity. See, if you see here, the lookup activity output value it is taking, right? It is going to iterate over those items. And what is the activity we are doing inside for each? We are copying one by one. Let's say lookup activity output is 2. So based upon each output, it will perform a copy activity of each and every activity. So if I click inside, edit, if I see copy, source is we have one data set, basically a source data set in the format of SQL Server, right? Table schema is nothing but a table name, which data type is as base table, right? And basically, if I preview the data, I am going to fetch all those data sets which are having table schema or the table type as base, right? So I'm iterating over those tables, right? If I close this, I'm closing this. So this is source. I am using a table schema. Table name is item at the table name. Data set name I have defined. And my sink will be a sink data set. Container target for each output. And you see if I go inside for each output, I have all these tables whose base type is whose type of table is basically nothing but base type, right? If I'm directly running this one, I can see the timestamps being updated. Close this for each, go to for each loop. Let me debug it. We'll see what happens. So basically, lookup activity will first go and look up into SQL Server based upon that query which we are passing. In that table, dbo dot items table, it will go and run this query. Select star from information schema dot tables, where table type equal to base table, right? It will run this query and first filter all those tables which whose type is base. Now it will iterate over those tables and copy it, right? That is the concept. So we'll see from 7th of Feb, the timestamp will change. I'm just updating this one. Once this is completed, we'll look up this is completed. Green signal came. Copy activity 1 passed. So we'll see which activity completed. Okay, these two tables got pasted. Other one is running. All the data copy completed. I'll refresh it. And you see all the date timestamp has been completed. So we have sales items.txt, which is nothing but this data set, sales items. So this table, dvo.sales items, along with in the for each activity, I'm also passing this query. What all tables of table data type as base type will be copied as a for each activity by using a copy activity inside the for each, right? So today's class, I just wanted to cover these three basic activities. Maybe in the next class, I will take you through the next different activities, and then we'll finally build a project on top of it. Hopefully you have liked the questions, the sessions. If you have any questions, do let me know. We can again connect and we can discuss over that. But yeah, please practice this exercises. I have already done it to, for saving some time. But yeah, we'll go through some more easier examples and then we will create one pipeline.
I hope everything is clear. If you have enjoyed watching this video, please do like and subscribe to Scalar's YouTube channel. If you want to watch similar content in future, do not forget to subscribe to Scalar YouTube channel. Thank you for watching this video. We'll see you again.